Welcome to Top Tips Tuesday, and this Tuesday the tip is to sketch out practical steps in a long experimental calculation to help you visualize what's happening. Now the image I've included has, lots of graphics and things like that on it, and of course you may be thinking, I do not have time to be drawing apparatus when I'm trying to be in the middle of a calculation question. So in this video I'm going to show you a couple of examples to show you that A, you do not need to be good at drawing at all, and B, that you do have time and that it's going to help you organise the information in the question so that you don't make stupid mistakes or miss things out. So here's my first example, and it is a waters of crystallization example. So this is really common where we're heating a hydrated salt that contains water, and we weigh it beforehand and then we weigh it afterwards, and we work out basically the empirical formula, how many moles of water there are per mole of salt. So this is how quickly you can sketch out what's going on, especially because people tend to get a little bit confused about what's going on. So I've got 13.2 grams of a solid, and the solid contains ZnSO4, but it also contains water. That's in a crucible, so you don't have to draw anything that really looks like a crucible at all. And I'm then going to heat it up. I'm now going to have less solid left behind. So I've used that information, 13.2. I've used the information about what it is, ZnSO4 with some water, and as I heat it, what's happening is the H2O is leaving as water vapour, and I'm left behind 7.4 grams of ZnSO4. Just by doing that little sketch, what it means is that I now know, I can't spell, I now know that ZnSO4 has a mass of 7.4 grams. And then I also know that the water in my sample is going to be the difference between them, 13.2 minus 7.4. That just helps me to visualize that. After that, I can use the MR values of those two compounds to work out the value of X. And if you like, you can carry on and work out that calculation yourself. Okay, what about this one? It's a titration question. And again, titrations can be nice and easy if you've just got a couple of solutions, but what's happening here is we've got a solid which is impure, so we've got this word contaminated. It's been dissolved in water, and then it's been titrated. So I would again just visualize the fact that I'm starting with a solid, and I also know that the formula of most of the solid is NaHSO4, but I know that it's not all NaHSO4, because if it was, I wouldn't need to do a titration because I've weighed it out, so I'd know how many moles I had. So we're taking that solid and we're putting it, this is where you really don't have to be good at drawing, in a flask of 250 centimeters cubed. And this is an important thing to kind of tick off as you're going along, because one of the key steps that people forget is that when we make up a standard solution in a volumetric flask, we don't use all of that solution in our titration. So we're going to take that, and actually this time it's been put into a burette. That's quite unusual. Normally we put our standard solution into the conical flask, but I do know that of that 23.1 centimeters cubed were used, and then I also know that there's going to be another solution in my titration, and I have the volume of that as 25 centimeters cubed, the concentration 0.1 moles per dm cubed, and that is NaOH. So how I would then use that little diagram to just work out what I'm doing is I'd work backwards through it. So from volume and concentration, I can work out moles of NaOH. From the question, I have a 1-to-1 ratio, so that gives me the moles of NaHSO4 in 23.1, because that's how much was required. So then I've got a tricky little step, because I know how many moles there are in 23.1, but I need to scale that up to how many moles there are in 250. Normally it's a nice easy scaling, like we take 25 out of a 250 centimetre cube flask and you just times it by 10. We can't just times this by 10 because doesn't go in so evenly. So what we would do to work out the moles of sodium hydrogen sulfate in the whole flask is I'm going to divide by 23.1. That gets me the moles in 1 centimetre cubed, and then multiply. You can do that in the same calculation, of course, by 250. That is scaling it to know how many moles of NaHSO4 there are in 250. That is the number of moles in my 5.678 grams, and remember, not all of that 5.678 grams is NaHSO4, so then I would times it by the MR. That would get me the mass, which should be less than 5.678 if I've done it correctly, and from that I can then work out a percentage purity. There are loads more calculation questions and examples of these and a few more tutorials on my website, so if you want to try some of these harder questions, go over to ckchemistry.co.uk and have a go. Even if they're quite challenging, they have video explanations, so you can look at the answers afterwards and see how well you did by practicing this technique.